Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with this class on trigonometric functions. So yes, there is trigonometric functions, and then there is another one which I accidentally cancelled off, deleted. So we'll be focusing on the inverse also, trigonometric functions and its inverse. So let's first get started with trig functions. Now, when we talk about trig functions, we talk about questions like these that you see on the screen. It's about a trigonometric function for a certain domain. They could be asking about range. They could be asking about the sketch of the graph. They could be asking about one-to-one and all these things, and an expression for G inverse. So let me just add a page over here. And let me write down few things related to functions that we have studied. So we have studied functions. And in functions, the input value, that is known as domain. These are the x values. The output, that is known as range. These are the y values, or you can say these are the fx values. When we talk about a function could be of two types. It could be one-to-one function, or it could be many-to-one. When we talk about one-to-one, one value of domain is giving us one value of range. When we talk about many-to-one, many values of domain giving you one value of range. Naturally, it's necessary there should be one unique value in the range. We are interested in one-to-one because only one-to-one function has an inverse. Inverse only exists for a one-to-one function. Graphically, when we talk about it, we are talking about that we apply the horizontal line test. If it cuts at one point of intersection, it means one-to-one function. If it's horizontal line test, if it's more than 1 point of intersection, then it's a many-to-one function. We should also be aware of the fact that we have the original function, we have the inverse function. The relationship between the two is reflection in line y is equals to x. The domain of original becomes range of inverse. The range of original becomes domain of inverse. A point such as AB, because of reflection in the line y is equals to x, gets converted to B, A. Remember by words, that is coordinates flip. Coordinates flip. And there is a process of finding expression for F inverse, which you have done in basic maths. And of course, you are doing it now. Expression for F inverse x, let y is equals to fx. Therefore, F inverse y equals to x. Let me just check one thing. Okay, all good, all clear. So now this is the process through which the inverse expression will be found. So these are a few of the things. Just have a good look at it. Some people are having an issue with the voice. There is no problem with the voice. Everyone has already said it's loud and clear. A few people, they also asked this question that we are studying trigonometry right now, and in the morning we studied integration. Yes, the morning thing, integration on Tuesday, integration on Wednesday, integration on Thursday, and then on Thursday evening, we will also do some more of integration. So that is a separate ball game. Let's talk about that later. So function, these are the few main things that we need to study. Okay, so now let's look at this particular question. All these questions are past paper questions. It says a function is defined by such and such. Find the range, sketch the graph. Now, one thing that we need to realize is that the range of f and the sketch, this could be done in two different ways. What I mean to say is that we can first find the range, then find the inverse, or then find the sketch, draw the sketch, or first draw the sketch, based upon the sketch, find the range. So both methods are possible. Now, what else do we need? We need the concept of y is equals to sine x. And if we talk about y is equals to cosine x, these are periodic functions because they take 360 degrees to repeat itself. So if I talk about sine, and let me draw a small graph over here. So this is the x-axis, just to give you an idea. And let me carry on this on the next page. And also over here, let me draw a straight line like this. And let me just shift it like this. Okay, so now if I draw the graph of sine x, that is one cycle, half a cycle like this, and half a cycle like this. That is sine x. When we talk about cos x, we draw it like this, and then like this. So just look at my working. How am I doing it? And then like this. So, of course, it is like this. So let me adjust it. I think that's good enough. So now over here, this is 0 till 360 degrees. So this is 0. This is 360 degrees. That is the period. The period for both, for this one and for this one, is 360 degrees or 2 pi radians. So there are 5 major points, just an overview. So let me just copy this thing, cut this thing from here. Let me add a page. And let me also add another page. So because I think I'll be needing more space for this. And over here, let me just erase this thing. And let me shift this thing up. Okay, so there are 5 major points. At 0, it's 0. At 90 degrees, it is giving a value of 1. At 180 degrees, it's giving a value of 0. At 270 degrees, it's giving us -1. At 360, it's 0. So remember this thing, the y values, that is 0, 1, 0, -1, 0. And over here, this is 1, this is 90, this is 180, this is 270, and this is again a 1 at 360 degrees. So therefore, this is, let me mark this thing, that is -1. So now the y values are 1, 0, -1, 0, and 1. And this is also one cycle. Now, this is the basic idea that we have. And if I look at this question, when I talk about the range, so the maximum value, when I talk about sine x, the maximum is 1. The minimum is -1. That is the same thing if I would talk about cosine x. So if I have fx is equals to -2 sine x plus 3, that's the proper way to write it. That is, first write this thing, excuse me, first write the trig function, because you can see the transformation. You have the sine x, and then you are multiplying it with 2, and then you are multiplying with the negative sign, and then you are adding a 3. So that is the transformation. Of course, we will have a quick session on transformation also. Maybe I'll make a video and then I'll share it with you. So in that one, we'll be talking about the different process of transformation. Fx is this thing. So if I talk about the range, so I'll write -2 into 1 plus 3 and -2 into -1 plus 3, because the maximum value over here, this thing over here is 1. So I'm plugging in 1 over here. And the minimum value is -1. So I'm plugging -1 over here. So basically, I'm doing part 1 first. So therefore, this is -2 plus 3, that comes out to be 1. And this is +2 plus 3, that comes out to be 5. So the minimum value is 1 and the maximum value is 5. Also, note this idea that 1, which is a greater value, is giving me a minimum, whereas -1 is giving me a maximum. Why is that so? Because of this negative sign, the graph is flipped in x-axis. Got the idea? Loud and clear? As far as sketching is concerned, you can just go ahead and sketch it. So fx is equals to -2 sine x plus 3. Now let me use the same colors. We are taking sine x and we are multiplying by 2. So if I show it in 2 steps, so that's sine x, multiply it with 2. And then what do? We flip it in the x-axis. So let me just draw a grid over here. So let me just choose this thing. Let me choose this thing over here. So this is right over here, -2 sine x. So I'm drawing it in red color. So this is one thing. And this is the other thing. So these two make up one cycle. Let me just draw it a bit bigger. Okay, that is perfect. So there are 5 major points: 1, 2, 3, 4, and 5. Now focus on sine x. The coefficient of x is 1. So therefore, 1 cycle in 360 degrees. But because of the 2 and the negative, it's flipped and it's what you call stretched along the y-axis. So this is +2, -2. Now what needs to be done? You have to add a 3 over here. So let me add this 3 over here. That is this one. That means these 5 major points will be shifted up by 3 units. So the 3 zeros will be shifted to 3. So this 0 will be over here, this 0 will be over here, and this 0 will be over here. All good? What about the 2? The 2 will be shifted to 5. The 2 will be shifted to 5 like this. What about -2? The -2 will be shifted to +1. So now let's draw in the same pattern as before. So let me just join this thing like this. That is one. That's half of the cycle like this. All good, all clear. And just ignore that if it's missing out. Something like this. Okay. Little bit more. Okay. So I think that is a perfect graph that I've drawn. 1, 2, 3, 4, and 5. So the purple one, that is y is equals to fx. And the reddish one, that is y is equals to -2 sine x. So now I can see if I just play around with the y-axis. So now over here, this is y, this is x. The maximum value is 5. The minimum value is 1. So the max is 5. The min is 1. And if they ask me for the range, so I can write it like this: fx lies between 1 and 5. So that is the first thing that I have done. So let me write down the question number. This is from trigonometry exercise. I think part of it was about function. Question 19, trig, and this is fx. So let's see how it goes. So just acknowledge if you have understood thoroughly this concept, that is this and this. So let me just, okay. So all good, all clear. That is about the first two parts. So now, if someone was not interested in doing part one, they could have drawn the graph and the answer would be right over here. Okay. Now let's move on to the other parts. Now it says a function gx is defined by such and such. So now we have part 3 and part 4, that is together. So that is part 3 and part 4, that is together. So now it says a function gx, the same function. This is 3 minus 2 sine x, minus 2 sine x plus 3. And this is for the domain x lies between 0 degrees and a degrees, where a is a constant. Now it says state the largest value of a, the greatest value of a for which g has an inverse. In other words, they are asking us that g is a 1-to-1 function. So in other words, g is a 1-to-1 function. It has an inverse. Inverse only exists for a 1-to-1 function. Now the story is about the turning point, because a turning point determines whether a function is 1-to-1 or not. Now, if I look from here, this is 0. Let me label the x-axis. So this is 0. This is 180. This is 360. This is 270. And this is 90. Now we see that if I apply the horizontal line test, currently it's a many-to-one function. But if I start from here, keep on going, and if I just stop over here, I don't rise up, that is a 1-to-1 function. It will fail the horizontal line test from here to here. Or from here to here, this is also a 1-to-1 function. From here to here, this is also a 1-to-1 function. That means if I draw portion of the graphs, just to illustrate this idea, so like this, and from here all the way up, no, it won't work. So hold for a second. Something like this, or something like this. So just to illustrate that idea, that from 0 degrees to 90 degrees. So this is 0 degree, this is 90 degrees, this is 90 degrees, and this one is 270 degrees, just to give you that idea. And now this is 270 degrees, and this is 360 degrees. So these are the different portions in which I would pass the horizontal line test. So if I draw from 0 to 80 degrees, it will still pass the horizontal line test. So the maximum value for which it's a 1-to-1 function, this maximum value is 90 degrees. If I start from 0, so therefore the value of a is 90 degrees. All good, all clear? So it's only for 1 mark, but it's very conceptual. Okay, so now let's move ahead. And let's look at the next part. When a has this value, that means it's a 1-to-1 function. When a has this value, obtain an expression in terms of x for g inverse x. That is pretty basic. So part 4, we will say let y is equals to gx. Therefore, g inverse y equals to x. So y is equals to this function, which is minus 2 sine x plus 3, negative 2 sine x plus 3. And then y minus 3 is negative 2 sine x. 3 minus y is equals to 2 sine x. I multiplied with a negative sign. 3 minus y over 2 is sine x. Therefore, sine x is equals to, actually x equals to. So x equals to sine inverse of 3 minus y over 2. But we know that x equals to g inverse y. So x equals to g inverse y, that is equals to sine inverse 3 minus y over 2. But we have a habit of writing everything in terms of x. So therefore, g inverse x is equals to sine inverse 3 minus x over 2. Let me double check everything. This is y minus 3 is negative 2 sine x. I first multiplied with a negative. So this is 3 minus y. This becomes positive. I divided by 2. Sine x is this thing. Therefore, I made x the subject. Sine inverse. Sine of this is this. Therefore, x is sine inverse of this thing. That is equals to g inverse y. Therefore, g inverse x is sine inverse 3 minus x over 2. So all good, all clear. So the rest of the parts, so the other parts regarding 1-to-1 and inverse and turning point or stationary point and the expression for inverse. This is all good, all clear. So this is one group, the other group, and the other group. Okay. So now this is all clear. This is the working that I did maybe last year or the year before that. So that's right over here, everything in one page and all this thing. Now, another question over here. And before this question, let me just shift around a bit. So let me first go to this particular question. Now have a look, good look at this particular question. So now this question says that the diagram shows part of the graph y is equals to a plus b sine x. State the values of the constants a and b. Now, how do we judge that it is still one cycle? One way of judging is that the coefficient of x is 1. Since coefficient of x is 1, that means one cycle in 360 degrees. What is the rule, by the way? When we talk about sine kx, or when we talk about cosine kx, right now I'm focusing on sine and cosine. The matter of tangent will come later on. The rule is k cycles in 360 degrees. We can also say that the new period is 360 degrees divided by k. Okay, so now over here, what we can do is that we have this thing, and we can see for ourselves that this portion, it's starting like this. Just focus on this. Focus with the flow. This is one whole cycle up till here. So this is minus pi to pi. That is 2 pi. 2 pi is 360 degrees. Got the idea? So now, what are we interested in? We are interested in a plus b sine x for 2 marks. First of all, the rule, remember this rule, very, very important. The amplitude, which is the coefficient of x, coefficient of trig function, not coefficient of x, coefficient of trig function, which in this case is b. That's right over here. So this amplitude is b right over here. And the other value is a. So this amplitude b, that is half the difference between maximum and minimum value. That is half the difference between these two values. Let me get the values. The big value is 3. The small value is negative 1. So this is 3 minus minus 1, which is 4 over 2, which comes out to be 2. That means the function is basically 2 sine x. So let me use this color. So the function is 2 sine x. The maximum value should have been 2. The minimum value should have been negative 2. But when we have 2 sine x plus a, but when we have 2 sine x plus a, the maximum is what? 3. And the minimum is what? Negative 1. So how is this value 2 becoming a 3? What are we adding? We are adding 1. How is this value negative 2? Let me choose another color. How is this value negative 2 becoming negative 1? We are adding 1. So therefore, this particular value that is being added, this a comes out to be 1. So a is that constant that is being added. We have b sine x plus a. So the value of b is coming out to be 2. The value of a is coming out to be 1. For 2 marks, that's the working that needs to be done. So I hope you realize this thing, that 1 mark does not mean it's easy. 1 mark means, yes, the working is less, but conceptually, yes, it is a strong question. So now question number 9, it's all good, all clear. That is about the amplitude thing. So let me write it down. So that is the amplitude, and that is the constant that is being added. Constant added. So these are the 2 things that we talked about. So let me share it to the other pages also. Okay. So now this is all good, all clear. Now let's look at this question. That is question number 34. And I would like you people to try it out first. So let me just pause the recording. Now, this question says, let me first read it out for you. The function is such that fx is a minus b cosine x lying between 0 and 360, where a and b are positive constants. The maximum value of fx is 10. The minimum value is negative 2. Find the values of a and b. Solve the equation. Sketch the graph. Now, since we are focusing on the function part, the solving equation, I mean, that's just the normal thing. So I won't focus much on it. My main focus is find the values of a and b and sketching the graph. So the working over here is that the coefficient of x, the coefficient of the trig function, that is b, that is the amplitude. And the maximum is 10, minimum is negative 2. So therefore, b is half 10 minus 2. That is half of 12, which is 6. So the value of b is 6. Negative 6 cosine x plus a, that is your function fx. Now, negative 6 cosine x plus a, the maximum value, the maximum without the a should be 6 and minimum should be negative 6. But since there is a negative sign, so it is flipped. That makes sense. So now, instead of 10, we are getting, instead of 6, we are getting a 10. Instead of negative 6, we are getting a negative 2. What is being added? 6 plus 4 is 10. Negative 6 plus 4 is negative 2. So the value of a, that constant that is added, that comes out to be 4. So I hope everyone got this thing correct. As far as sketching the graph is concerned, let me show you the working. That's right over here. So this is negative 6 cosine x. So the red one, that is negative 6 cosine x. One cycle in 360 because the coefficient of x is 1. And then we are adding 4 over here. So what we are doing is that we are adding a 4 over here. So 6 becomes 10 and negative 6 plus 4 is becoming negative 2. So the maximum value is 10. The minimum value is negative 2. The sketch is drawn and the rest of the working is the same. I did not focus on the equation part. That is for basic trigonometry. This thing is done. Now let's look at this particular question. Again, the question is about this thing. The function f is such that fx is 2 sine square x minus 3 cos square x for x between 0 and pi. Express fx in this form, stating the values of a and b. Find the greatest and least values of fx. Right now, I'm not interested in the last part. So let me just erase this thing. So I'm not interested in solve the equation fx plus 1 equals to 0. So let me just erase this thing. And let's focus on the first two parts. So now fx is equals to 2 sine square x minus 3 cos square x. We want everything in cos square. So we know that sine square plus cos square equals to 1. Let me just double check one thing. The voices all got all clear. Perfect. So sine square plus cos square equals to 1. Therefore, sine square is 1 minus cos square. This sine square will be replaced with 1 minus cos square. So that is 2 bracket 1 minus cos square x minus 3 cos square x. That is 2 minus 2 cos square x minus 3 cos square x. Therefore, this is 2 minus 5 cos square x. That is fx. Now it's asking for the greatest and the least values of fx. So the greatest and the least values of fx. Now the thing is, cosine x has a minimum value of -1, a maximum value of 1, and an in-between value of 0. When we talk about cosine square x, this -1 after squaring will become 1. 1 after squaring will remain as 1. 0 after squaring will become 0. So now in order to find this thing, since we cannot sketch the graph, so sketching cos square x or sketching sine square x for that matter is out of syllabus. So I cannot sketch and get this idea. I'm working between 0 and pi. So these are the values that I'll come across. And I have squared this one. So this becomes 1, this becomes 0, this becomes 1. So that means f of x could have a value of 2 minus 5 times cos square x is 0. And fx equals to 2 minus 5 times 1. This is giving me 2. This is giving me 2 minus 5 is -3. Therefore, the maximum value is 2 and the minimum value is -3. It's kind of a different kind of question. Have a good look at it. So let me know if this is all good, and I'll do it in some other ways also. So therefore, this cosine square question, it's about range. So that is how we do this. Cosine square question and its range. So let me share it in the other groups. A is 1 and then A is 2. Okay. Now let me change the question. How will I change it? Let's have a good look. Let me add a page. And over here, I'm writing this thing. Express fx in the form, instead of a plus b cos square x, let me write q plus r sine square x, stating the values of q and r. And then we are interested in state the greatest and least values of fx. So we are interested in the first two parts like this. And this part, let me just erase it. We are not interested in this last part. Now, if I do the change over, fx is equals to 2 sine square x minus 3 cos square x. And then we have the identity that is sine square x plus cos square x equals to 1. This time I'm interested in changing this out. So cos square x is 1 minus sine square x. So this is 2 sine square x minus 3 bracket 1 minus sine square x. This is 2 sine square x minus 3 plus 3 sine square x. This is 5 sine square x minus 3. This is your fx. Again, the same scenario. Sine x will have a minimum value of -1, a maximum value of 1, and in between value of 0. I'm interested in sine square x. So this is -1 square, which will become 1, 1 square, which will become 1, 0 square, which will remain as 0. So this is 0, this is 1, this is 1. In order to find the maximum and the minimum, so therefore what I'll do is that fx is equals to 5 sine square x minus 3, 5 sine square x minus 3, fx is equals to 5 sine square x minus 3. The smallest value is 0. Let me pick 0. And the other value that I have is 1. So 5 minus 3 is 2. 0 minus 3 is -3. Therefore, the minimum value is -3. The maximum value is 2. The minimum value is -3. The maximum value is 2. So there are two ways in which I have done the question. One in which the examiner guided me to do it. The other one that was out of the box. I made you realize that the examiner could someday ask the same question by stating this. So what is the value of Q? Let me write it down. What is the value of Q? Q plus R sine square x. So this is Q and this is R sine square x. So the value of Q is -3. The value of R is 5. If it's written in terms of sine square x. Over here, this is A plus B cos square x. The value of A is 2. The value of B is -5. So I hope this is all good, all clear. Okay. This is what I did from last year. Another question of this sort. I would like you people to try it out. Question number 18. Let me pause the recording. So now question number 18, it's about this concept that is similar to that. Fx is equals to this. It's defined for the domain 0 till pi. Express fx in this form, a plus b sine square x, stating the value of a and b, state the range of f. Exactly the same thing. So now this is 5 sine square plus 3 cos square. Cos square is 1 minus sine square. We simplify the things. This becomes 2 sine square plus 3. We know that sine of 0 is 0, sine of 90 is 1, sine of 180 is 0. When we square it, 0 square is 0, 1 square is 1, no issue. Plug in 0, plug in 1, and we are getting 3 and 5. Minimum value is 3, maximum value is 5. The only thing different that I did over here is that I wrote down for which value. For sine of 0, I'm getting a 0. And in the question that I did right now, I simply wrote the value because these are the extremes that I'm getting, -1, +1, and 0. In this one over here, in this particular range, since this is between 0 and 180, -1 does not occur. So 0 square is 0, 1 square is 1, the smallest value is 0, the greatest value is 1, and that's how these values are obtained. Okay, another question. Why don't you go ahead and try this one? That's also a very nice question. Let me pause the recording. So now this question, let me just erase this. Now this question is about this idea that the graph is drawn. The graph shows part of the graph a cosine x minus b, where a and b are constants. The graph crosses the x-axis at this point and the y-axis at this point. Find C and D in terms of A and B. Now, let me tell you a property which is something very common. You have used it. For example, if I say sine of 30 degrees is 0.5, so sine inverse of 0.5 is 30 degrees. Of course, there are other values also, but we are just focusing on this acute angle value. If I write sine inverse of 0.5, what exactly am I talking about? Sine inverse of 0.5, let me use a red color. Sine inverse of 0.5 is 30 degrees. This is 30. And sine of 30 will give me 0.5. Got the idea? Let me write it in another way. Sine inverse of sine of 30 degrees. What is sine of 30 degrees? Sine of 30 degrees is 0.5. So this is 0.5. And sine inverse of 0.5 is 30 degrees. That means if there are two functions which are inverse of one another, then whatever this value is, that value will be written over here. If there are two functions which are inverse of one another, whatever this value is, that value will be written over here. So therefore, this is a property of composite functions. In one of the classes, I have not done it. So don't worry about that. I'm just using the basic idea. F of f inverse x equals to x, f inverse of fx also equals to x. That is the property. And this is the example. Now, why am I interested in this? Because look at this question. Y is equals to a cosine x minus b. If I plug in the point D right over here, so let me plug in D, which is x is 0, y is d. So therefore, d equals to a cosine x minus b. This is equation number 1. Leave it as it is for right now. Focus on the other point, which is C. So C is cosine inverse C, comma 0. So this coordinate, what it means is that, let me just erase this. This is when x is cosine inverse C, y comes out to be 0. So if I plug in over here, this is 0, this is a, this is cosine, and instead of x, what are we writing? Instead of x, we are writing cosine inverse C. And then we are writing a negative b over here. All good, all clear? Y is a cos x minus b. Instead of y, I'm plugging in 0. Instead of a, I'm writing a. Instead of negative b, I'm writing negative b. Instead of cosine, I'm writing cosine. Instead of x, I'm writing cos inverse c. Now, does this ring any bell? Is it like this? Cosine of cosine inverse c should equal c. Cosine of cosine inverse c should equal c. So therefore, what do we have? We have 0 is equals to a. This whole thing becomes c minus b. All good, all clear? So this thing is basically, let me just erase this thing. So like this. So therefore, this thing is this thing over here. And we want c and d in terms of a and b. So therefore, AC is equals to B. Therefore, C is B over A. That is what you get. And over here, we have X is 0. So let me just write one thing over here. Over here, we have X is 0. So this is cosine of 0 minus B. I can further simplify it. Cosine of 0 is 1. So therefore, D is equals to A minus B. That is one answer. So let me highlight it over here. D is A minus B. That's one answer. C is B over A. That is the other answer. So just acknowledge it on the WhatsApp. This is question number 38 that I have just solved. So question 38, let me go over here. And this is all good, all clear. Question 38, AS1, AS2. Okay. Okay, others, they can also acknowledge. Thank you. So that's how this thing is done. Okay, this is from last year or something. Now, this question, I'll keep it on the sidelines for right now. And let me go to a question related with tangent. Okay, have a good look at this particular question. And I would like you people to try this out. Let me share this thing. And this is export over here. So try out question 22. Hold for a second. This is question 22, 1 group, 2 group, 3 group, and try out. So let me just pause the recording so you can comfortably try it out, and then I'll let you know the solution. So the recording is paused. Now, this question is about tangent. The question says, a function f is defined by fx is 3 minus 2 tangent half x. This is 3 minus 2 tangent half x for x between 0 and pi. State the range of f, sketch the graph of y is equals to fx. So these two parts are linked. Okay. And then we have a part that is about state the exact value of f of 2/3 pi. That is different. And similarly, we have a last part, which is about obtain an expression in terms of x for f inverse x. Now, let me start with the easy part. The easiest part is part 4. We have y is equals to fx. Let me just check the voice. Yeah, it's all good. So we have y is equals to fx. Therefore, f inverse y equals to x. That is the traditional thing that we write. This is the input. It gives us an output. In the inverse, when we plug in the output, we will recover back the input. That is the logic. So now over here, if I write y is equals to 3 minus 2 tangent half x. Y minus 3 is negative 2 tangent half x. 3 minus y is 2 tangent half x. 3 minus y divided by 2 is tangent of half x. Tangent inverse of 3 minus y over 2 is half x. Therefore, 2 tan inverse 3 minus y over 2 equals to x. What is x equals to? X is f inverse y. X is f inverse y. We have a habit of writing everything in terms of x. So f inverse x is 2 tan inverse 3 minus x over 2. That is the answer for part 4, and it's for 3 marks. So this is 3 straightforward marks, provided you know the step. Go through the steps once more. You replace fx with y. You make x the subject. Step by step, show every single detail. Once you achieve x, what is x equals to? F inverse y. And this is just change of variable. So all good, all clear? Now let me also focus on the second part. The second part is the exact value of f of 2/3 pi. F of 2 pi divided by 3. Now what's on the inside? Tangent of half x. So let me focus on that. Tangent of half x, I'm just focusing on this. That is tangent of half into 2 pi by 3. That becomes tangent of pi by 3. We know that tangent of pi by 3 from the basic ratios thing, this is root 3. So we have fx is 3 minus 2 tangent half x. Fx is 3 minus 2 tangent half x. F of 2/3 pi, this is 3 minus 2 tangent half of 2/3 pi, which I have already evaluated. So this thing right over here, let me use a highlighter. So this thing right over here, let me use a green one. tangent half of 2/3 pi. This is what? This is √3. So therefore, the answer is 3 minus 2 √3. That is the answer in the exact form. That is the exact value. All good, all clear. So I got rid of these two parts, part 4, part 2. And this is perfectly fine. You can do it in the exam also. So let me add a page over here. Okay. Now I'm interested in part 1 and part 3. So I am interested in part 1 and part 3. So this is part 1, this is part 3. State the range of f and sketch the graph. I think it's very easy to sketch the graph first. So therefore, part 3, I'll sketch and I'll state the range. Fx is equals to minus 2 tangent half x plus 3. First thing first, let's start underlining. I'm interested in tangent half x. I'm interested in doubling it. I'm interested in flipping it. And then I'm interested in adding a 3. So when we talk about tangent half x, that means half cycle. Actually, let me write the rule first. When we talk about tangent, so now the rule is y is equals to, let me correct this thing, y is equals to tangent kx. The rule is 2k cycles in 360 degrees or 2 pi radians. Therefore, in 180 degrees or pi radians, I have just a k cycle. So whatever is the coefficient of x, that means tangent half x, half cycle in pi radians. All good, all clear? That's based upon this. So when we talk about half a cycle for tangent, let me draw this thing. Hold for a second. Let me get this thing ready. So now when we talk about tangent, when we talk about half a cycle, so that is like this, and that is like this. This is a full cycle. This is 0 till y is equals to tangent x. This is 0 till pi. If I talk about y is equals to tangent half x, so then half a cycle in pi radians. So this is actually pi radians, half a cycle. So let me write over here, this will become pi, and this will become 2 pi. So therefore, I am interested in this part only, half a cycle in pi radians. But then there is 2 and then there is negative. So let me draw it again. So therefore, let me have a 2 with a negative sign. So this is 2 with a negative sign. So this will be going down like this. Let me make it more steeper like this. And let me also draw a dotted line like this. Okay, so now let me label it. This is 0. This is pi, half a cycle in pi radians. And somewhere here is pi by 2. All good, all clear? So now let me label this negative 2. That will be corresponding to this. How do I know this? We know that tangent of pi by 4 is 1. When I plug in tangent of half of pi by 2, that is tangent of pi by 4. So this will give me 1. But because of this negative and this 2, it's flipped and it's like this. And then what needs to be done? We need to raise it up by 3 units. So first of all, let me just copy this. And let me just paste it over here. Let me change the color to purple. And let me shift this graph up by 3 units. So like this. So therefore, the 0 value is now 3. That is the maximum value. This is y-axis. This is x-axis. They're asking for the range. So the range is fx lies between 0 and pi, actually infinity and pi, or fx is less than or equal to 3. I think that is much easier to write. So if x is lesser than or equal to 3, that is the range of this particular graph. Now, this one was a tough one. So part 3 is done. Part 1 is done. So let me write over here. This is part 3. This is part 1. Let me write it. Hold for a second. So part 3, part 1, flip, stretch. You cannot see much stretch over here because this is tangent. This is number of cycles. So let me focus on everything and you are having a look at it. And then it's a translation parallel to y-axis. So this is all good, all clear. So this is like this. This is one group and this is the other group. Okay. And this is what I did last year. More or less the same thing. That is the exact value. That is the expression. That is the graph. That is the range. That is the basic idea. That is about the period and everything. So I think I worked the same thing on 2 different pages instead of 1 single page. Okay, so now let me move to this one. That is the inverse thing. And let me make a separate video for this. So trigonometric function and its inverse, let me make a separate video for this because this will be requiring more time. So I think we have done enough for today. So let's stop the recording over here and let's meet in the next class. Take care, everyone.